Okay, so here's a real practical problem. I mean, you're given a certain amount of material and to build a cylinder, and it's going to be 3 pi square feet of material. I know it seems like a weird number for the size of the material, but it's going to make the problem just have a nicer looking answer. And so we're given a certain amount of material. We want to build a cylinder such that it's got the maximum area possible. Okay, so let's look at the equations that we'll be dealing with. Okay, so the first equation that we're going to be dealing with is the volume. So the volume of a cylinder is pi r squared h. Okay, and but we need the equation of the surface area of the cylinder. Notice one thing about the problem. It says a cylinder with no lid. It's got a base but doesn't have a lid. Okay, so the surface area would equal pi r squared. That's going to be the area of the base, and 2 pi r h. All right. So this is the base. If you were having a cylinder with a base and a lid, you would say 2 pi r squared. Okay, but we only have a base to this problem, so it's just pi r squared. Okay. And it says it is made from 3 pi square feet of material. Okay, so what is that? That means that I'm going to write it like this. Pi r squared plus 2 pi r h is going to equal 3 pi. And so that's the constraint of the problem, that it's only got 3 pi square feet of material. Okay? Okay, so we want to turn the volume into a function of one variable. I don't think we're going to get it as a function of h. So let's get it as a function of r. Okay? So to do that, let's solve for h. Okay? So I'll do this kind of slowly. So this is going to be 2 pi r h. It's going to equal 3 pi minus pi r squared. Okay. Or that h is going to equal now 3 pi minus pi r squared divided by 2 pi r. Okay. Okay, so the reason that pi was in there is so that the pi's cancel out. Okay. So the pi's cancel out, and so what are we going to get from this? Okay, so that would be 3, I'm going to write it like this, 3 over 2r minus, now r, sorry, that's a minus, divided by 2. Okay? That's a subtraction sign right there, and that's an r. All right? And so we're going to plug this h back into our volume. All right? So the volume would equal, all right, so this is pi r squared, and then multiplied by h, which is 3, divided by 2r, minus now r divided by 2. Let's do a little bit of simplification. So if I multiply pi r squared by the first component, one of the r's is going to cancel out. So that will be pi times, I'm going to write it like this, 3 times r divided by 2. Okay? And then minus pi, now this is being multiplied by r squared, so that's pi r cubed divided by 2. Have to start a new sheet. Okay, so right now we have the volume as a function of one variable. And so what we're going to do is we're going to take its derivative with respect to that variable and set it equal to 0. So let's say the derivative of the volume with respect to the radius is going to be pi times 3 divided by 2, because that guy just had an r on there. So it just takes it from a linear form to a constant form. Now the other one is r cubed. Okay, the derivative of r cubed is going to be 3r squared. So minus pi times 3r squared divided by 2 is going to equal 0. Okay? So what is this going to give me? I can move, well, let's do it like this. Negative pi times 3r squared divided by 2 is going to equal negative pi times 3 divided by 2. Okay? All right, I can multiply negative 1 on both sides of this problem, making both sides positive. I can multiply both sides by 2, and the 2's on the bottom disappear. And then I can divide both sides by 3 pi. And so what do I end up with? The r squared equals 1. Okay? All right, so when we take the square root, we get r is going to equal plus or minus 1, but that doesn't make any sense, so r is just going to equal 1 foot. You'll just take the positive part and ignore the negative part of the problem. Okay? Okay. Now let's go back just a bit. Okay, so we have from this part, where are we at? Right here. We're going to return to this part right here, and I'm going to use this to solve for h. Okay? So, h is going to be 3 divided by 2 times 1 minus 1 divided by 2. Okay? Well, that's just really 3 halves minus 1 half. So 3 over 2 minus 1 over 2 is just going to be 1 foot. Okay? So the height and the radius are the same. And so those are the dimensions that will maximize the volume of your cylinder.